Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, we provide workshops and exercises to learn about AWS services. These workshops and exercises are published to our website aws-dojo.com, and you can follow those workshops and exercises to implement certain scenario and learn about AWS services. Today, we are going to talk about AWS IoT Device Defender. It is a service which is used to defend your devices from, and of course, your IoT core from various types of attacks. So let's get some introduction about this service first. So AWS IoT Device Defender is used to protect your devices as well as AWS IoT Core. So it works in a pretty simple way. So your devices which are sending the messages to the AWS IoT Core using, say, MQTT protocol, they send a lot of security matrices along with the messages. Those matrices as well as your IoT configuration both are audited by your AWS IoT Device Defender, and if there is something into those configuration or into your security matrices which is not usual, which is a threat to the system, a potential threat to the IoT core, or it gives an indication that device has been compromised, then it throws alert. And then those alerts you can either see on IoT console, or you can also send it over to SNS topic, which then can be used to handle for the automation. You can also send it to CloudWatch matrix, by the way. So another thing to add is that when this IoT Device Defender recognizes some kind of threat or finds some kind of alert for certain kind of device behavior or IoT configuration, then it can also trigger remote device operations, like things like you want to revoke the permission of the device, or you want to reboot the device, or you want to update some kind of security patch on the device, and those kind of things. What is important for you to understand here in this setup is pretty straightforward, guys, is that your IoT Device Defender looks into two types of configurations primarily. The first type of configuration is your IoT configuration of your device, your things itself. So for instance, it will look into best practices of your IoT configuration. So it will check for things like, are there more than one devices which are sharing the same certificate? Then it will raise alert for that. It will check if any of the device has got an over permission to what ARN or what resources can publish or subscribe messages to. If it sees that certain device has got more than required permission, then over permission, then it will raise alert for that. So one aspect of the review is review of your IoT configurations from the best practices point of view, and if those best practices has not been followed, then it will throw alert. So when you go and configure this part, it's pretty straightforward. It will show you the list of different best practices. You can select which one you want to enable, which you don't want to enable, and for the ones you enable, if any violation happens from those in those best practices, for those best practices in IoT configuration, it will throw alert. Now comes another part which is very interesting, is it can also look into your security matrices. So when your device is sending messages, a lot of matrices are getting published. So things like how many times device authenticated, how many times authentication failed, how many connect event happened, how many disconnect event happened, how many messages got sent, how many, what is the size of the message. Those kind of matrices also get published. And what you can do is in IoT Device Defender, you can create a security profile saying that if any of these matrices show behavior as abnormal, then that means the device has been compromised. And in that case, you want to throw alert and either get notified about it or do some kind of remediation action. So a simple example will be, which we are going to do in our scenario today. Suppose that you know that your device will not send more than 3 messages in 5 minutes. Yeah, I mean, that's the frequency of your device just sending the messages. And in that case, if your device starts sending messages which are more than 3 in 5 minutes, then you will assume that your device has been compromised and it is probably trying to do some kind of DDoS attack on your IoT code. And in that case, you want to raise alert about your device. So things like that. In security profile, you can use security matrices to create rules for device behavior, that what I will treat as a abnormal behavior from the device, whether it's a message count, number of connects, disconnect, number of authentication failure, number of message sizes, etc. Any of those, there are a number of matrices both on the IoT core side and on the device side. And you can use those matrices to create a rule that if these matrices show this kind of pattern or behavior, then it is abnormal behavior, and I want to raise alert about it, or possible remedial action if you want to do. So that's exactly how Device Defender works. Either you can create a security profile to check on the security matrices, or you can use best practices check on your IoT configuration to see if the device has been configured, the IoT core has been configured in a proper way to the best practices as recommended by best practices in AWS IoT. Cool. So having get introduction about that, this is what we are going to build today. So we will configure, so we don't have any physical device here, so we are going to do device simulation through a Python code running inside Cloud9. And then you will configure this device as a thing where this code will send MQTT messages. Then we are going to create a security profile and AWS IoT Device Defender. And this security profile says that if number of messages exceed certain numbers, then that means the device has been compromised, it's trying to do some kind of DDoS attack on AWS IoT core, and you want to raise alert about that. In order to raise the alert, it will send notification to the simple notification service topic, and then simple notification service will simply send the alert over email notification. So this is what we are going to build today to understand how Device Defender works, especially the security profile part of Device Defender work, because that's where you can really check on the behavior of the device using security matrices. So in order to do this exercise, we have a workshop which has been published to our aws-dozo.com website. We have provided the URL of this workshop in the description box below. What I'm going to do next is that I'm going to walk you through the steps of this workshop to understand what exactly is happening, and I'll give some more context around different types of configuration we are doing. And post that, you can visit this URL to do this workshop by your own. I mean, yeah, it provides you step-by-step instructions to implement the scenario we just discussed, and you can simply follow the instructions to complete the whole workshop, the whole lab, and learn about AWS Device Defender. So let's move on to the workshop quickly. So moving on to the workshop. So we already discussed about some of this introduction over here. So let me quickly jump to the workshop. So click on the link called Start the Workshop to start your workshop. And it will show you the number of steps and the sequence of steps you have to perform to complete the workshop. You can see you have to perform roughly 8 steps, cleanup and prerequisite included. So you have to click these steps one by one to complete your job in the sequence. So let's go to the prerequisite step. And in the prerequisite step, the first prerequisite is that you need to have an AWS account in order to complete this workshop. And if you don't have, you might want to use this link to create one account. Now, for this lab or workshop, we have assumed that you know how device to IoT core communication work, how the MQTT messaging works, how this whole publish subscribe model works. If by any chance you don't know, okay, if you know, then good enough, you can move forward to the next step. But if any chance you don't know, then you might want to visit these two other workshops in where in one workshop we talk about understanding the device to IoT core communication, and the second part we talk about how to use Python code to create such communication. Because in this lab we are going to use the Python code, so I assume that you understand the communication method and you also understand how you can write a Python code to create such communication, because that part we are not going to focus today. Okay, so if you know this part, good enough. Otherwise, please use these two links to get that knowledge, and then you come back and then you can continue working. Okay, so let's go and create IoT role. So AWS IoT Device Defender is going to say call SNS service and many other services to able to publish your alerts for the devices. In order to do so, it needs to be authorized. And for authorization purpose, we are creating a role over here. And this role will be used by AWS IoT Device Defender to make authorized call to other AWS services. So we go to IAM, say I want to create a role, then you select AWS IoT service as a service over here. And then you can see here we have given this IoT service over here, and then it gives certain permission automatically to this role, and then we give this role a name called Dojo IoT role, and simply we create the role. Okay. Now the default permission for this role is that it can do IoT logging, it can trigger rule action, it can register the thing. Well, in this case, we need to send a message to SNS topic. So what we'll do that we will go and update the role and say, I want to add another permission calling, say, Amazon SNS full access. Okay, well, I'm going for full access here, which is not a best practice, I understand, but I try to keep it simple. In a particular scenario, you might want to restrict that, okay, this role will have only publish permission to certain topic inside SNS. Okay, that will be more appropriate way of doing that. But for now, we kept it simple. So you simply add one more access to SNS so that AWS IoT role can send the alert to SNS topics. Next, let's go create an SNS topic quickly. So we go to our simple notification service. I say I want to create a new topic. We give this topic a name called Dojo device topic. And then after that, your topic is created. Then we want to create a subscription, because the subscription, we need to create subscription to get alerts when some message get published to this topic. So in this case, we go and create subscription. And since we want to use email-based subscription, we simply go and enter a valid, like your protocol as an email, and a valid endpoint, email ID as an endpoint. And then you simply create the subscription. When you create a subscription, since it is email subscription, it is in a pending confirmation stage till the email owner actually confirms that it is okay with the subscription. So a subscription email has been sent to your email ID which you provided. You go over there, you click on confirm subscription so that your subscription is confirmed, and then you can come back and see that your subscription has been confirmed. Now with this configuration, when AWS IoT Device Defender sends a message to the topic, it will send an email alert to the email you have just configured with the subscription. Cool. So having done that, let's start with your registration of the device. So we go to the device registration. We go to the IoT core and say I want to, okay, before we create a device, we need to create a policy for a device which will give certain kind of permission to the device. So we click on create a policy. We give this policy a nice name, Dojo device policy. We give it certain permission, and we simply create the policy. So once the policy has been created, then we go and create a thing. We register the device. So we say, okay, I'm registering a thing or a device. I want to register a single device. We give it a nice name called dozer device one, and then it will say, okay, how do you want to add certificate to the device, and say, yeah, because your device use X509 client certificate based authentication. So you simply say, I want to create certificate. It will generate certificates for you, which you have to download, because this certificate has to be copied to your client code, so that client code can use this certificate for the authentication purposes. So you simply go and download this certificate. And once you have downloaded the certificate, you activate the certificate, and then you attach a policy to the certificate. When you attach a policy to the certificate, then the device will have the permission defined in this policy. So, and for policy, we simply go and select dozer device policy, and we simply save it. So what you have done here is that you have created a policy, and then you created a device thing. You generated certificate for device thing, you downloaded it so that your client code can use that certificate for authentication purpose. Then you associated that certificate with a policy that the device, so that when it does certificate based authentication based on the policy, it will be authorized to make call to AWS IoT core, and then yeah, you simply save it. And at this point of time, when your device is created, you go to the interact menu over here, and you make note of this broker address, because this broker address, the client code need to know, or the device code need to know the broker address in order to make call to the AWS IoT core. So you make note of this broker address. Okay, so your device is ready now. Now let's create a security profile for a device, so that if device sends more than expected number of messages, then it raises a security alert. So for that we go and create security profile, and in AWS IoT core, you go to your defend, then intro. You can go to detect also, and simply click on create your first security profile, when I'm using for the first time for this demo at least. And then here we start creating the profile. So we give it a nice name called dozer security profile, and then we start defining the behavior. Now you can define more than one behavior, and when I tell you explain the behavior, you will understand what exactly the behavior means. So for instance, in this behavior, we are giving a name called message count behavior, and we're saying I'm putting a check on matrix messages received, that how many messages the IoT core receives from a device. Okay, and then say I want to check absolute value in this case. Yeah, you can check stats value as well. And then I'm saying if the messages received are greater than 3. Okay, so if a device is sending more than 3 messages, in what duration? 5 minutes. So within 5 minutes, if the device sends more than 3 messages, then that behavior is an alert behavior. That's what we are saying here. Then data point to alarm, that how many such occurrences should happen. I mean, a device might send like once more than 3 messages in 5 minutes, or it can send more than 1. So in this case, we are saying 1 means my threshold is very low. Even if once the device sends more than 3 messages within 5 minutes, it's an alert. Okay, and then if it goes back to normal, that it starts sending less than 3 messages, less than or equal to 3 messages, and even if once that happens, that means my alert is clear. Okay, so I have basically said here is that if your message counts goes more than 3 even once, then raise an alert, and if the message count becomes less than or equal to 3, then we say, okay, device is not a threat anymore, and we revoke the alert, or we go from alert to the normal state. Yeah, not revoke the alert, but go from alert to the normal state. Okay, and you can add many other behaviors like that using different types of matrices, like your authentication failure, your number of counts, connect counts, disconnect counts, message size. Yeah, you can really play with it. Yeah, there are n number of matrices over here you can use. So having defined my device behavior over here, then we move next, I said, okay, once you have defined the device behavior, what happens when this device behavior occurs? I mean, if more than 3 messages come, then what we do? And you're saying that, you know what, simply publish this alert to Dojo device topic. This is the topic we created earlier. And they say, okay, fine, which role it should use to authorize such publishing? And then Dojo IoT role you created earlier, you simply say, I want to publish that. I want to use that role for authorization to publish this message to the AWS IoT and to the device topic. Now it says, okay, this behavior or this profile we just created, is it applicable to what? And you have a choice, like you can say all things or only unregistered things or registered things, or you can also create different groups of your things and you can assign it to a specific group. Okay, so you can also, when you register your device, you have a choice to go and create multiple group of your devices. And then if you do so, you can here and say, okay, this profile I'm creating is for this group of devices. And it is very important because if you have different types of devices, then some device might send very frequently messages, some will not send that frequently messages. Then you might want to create different security profiles for different group of devices. And in this case, each profile you can assign to a specific group. But in this case, I have only one device. It is straightforward, simple. So I'm saying, okay, all things apply. Okay. And then simply we confirm our security profile. Now our security profile is ready. Now it's time to go and write the client-side code, which will send more than 3 messages within 5 minutes. So first thing first, since we don't have any physical device over here, we are using AWS Cloud 9 for our to simulate our client-side environment, writing the Python code. So we simply go and launch a Cloud 9 environment. We are simply launching a Cloud 9 environment, Dojo environment. Once, and we select your instance type, and your operating system is Ubuntu server, and so we simply launch the environment. Once we launch the environment, you might want to check what Python version is running, what Python 3 version is running. Is 3.6.9, which is good enough. Then we need to install AWS IoT device SDK, because in order to write the client-side code in Python, you need to have AWS IoT device SDK for Python installed on this box or in this environment. So we simply we do git clone we clone this repository where your device SDK is stored. Then we move on to this folder, AWS IoT device SDK Python, and then we simply run the command setup.py. We run the file setup.py install. And when you do that, it will simply install AWS IoT device SDK for Python. And then we simply go back to the root directory, because my environment is now configured to write code to publish messages to AWS IoT core. Now, as I mentioned earlier, that when you're writing your client-side code or device code, then you need to authenticate using the device certificates. So we need to upload device certificates here in this environment. And remember that one of the previous steps, we downloaded the certificate on your local box where you're running this workshop. Now we need to upload that to Cloud9 environment so that the client code can use those certificates to make call to AWS IoT code and publish the messages. So in order to do so, we simply go and say, I want to upload the local files. And then you upload your root certificate, your X509 certificate, and your private key. Okay, so these 3 files you simply upload, and with this your Cloud9 environment is ready to not rock the code, but write the code. Okay, so you go to the next step, which is writing client code to send messages. And in this step, actually, you go simply create a new file, and this is how the code of the file look like. So you first go and create an MQTT client, and you give device a nice name. Then you simply configure your endpoint, and this is your broker address. And remember, this has to be replaced by the broker address you noted when you registered your device. And then client is talking to this broker address over port 8883. Then you configure your credentials. So remember, again, you have to use the X509 certificates and for certificate and key for the authentication. So we're simply providing here the root certificate, your X509 certificate, and your the private key and X509 certificate. And here the name is this name because that's the name of the certificate generated. In your case, when you're doing this workshop, your name could be something else. In that case, simply update the name of the certificate you have. Then we write this MQTT client message connect method to simply connect the client. And then we are simply, this is the message I want to send, and I want to send this message to this topic. This is the topic inside MQTT where I want to publish the message. Again, if you don't understand this, what I'm talking about, probably you don't understand how device to AWS IoT Core communication works. I have already provided link to two workshops in the prerequisite step, which you can follow to learn about this method or this technique. Okay, so we are publishing this message to this MQTT topic. And then if you see here, we are doing a trick part, which is we are sending more than 3 messages, because the rule is that if the messages count in more than 3 within 5 minutes, then that's an alert situation. So simply sending the 5 messages over here, and then say, okay, confirm that 5 messages sent, and then you're simply disconnecting. Okay, so job done. So I mentioned that you update the broker certificate and everything. Then you simply save this code as a publish.py, and then you simply run this code. When you run this code, it will simply connect, send the 5 messages, and it will disconnect. Now, the message has been sent, and remember the rule was that it will check for device behavior, like more than 3 messages. That behavior it has checked for 5 minutes in a span of 5 minutes. And in the span of 5 minutes, even for once, if more than 3 messages has come, then it's a alert situation. So you have to unfortunately wait for 5 minutes, because the device defender is waiting for 5 minutes span to see are there more such occurrences happening. Okay, so in this case, when you do that, you wait for 5 minutes, and then you'll see after 5 minutes, the device defender will recognize, oh, there has been one incident where more than 3 messages had been sent to me within last 5 minutes. That's an alert situation. It will publish that alert to the SNS topic, and then SNS topic will simply send the message over email, because that's what we configured as a subscriber. Okay, and you get a message like that where you can go and see the alert in detail. Now, here in this case, we decided to get a notification over email, but really you can you can do a very smart thing in the sense that you can subscribe a Lambda function for the topic, and then when Lambda function receives this message, this information, it can go to the device and say, okay, I'm going to say, for instance, deactivate the certificate of the device, or I want to remove the policy of the certificate. I mean, yeah, you can do those kind of corrective actions to ensure that, because this is the case, probably you're assuming that this device has been compromised, and it is and its client code had been updated to kind of do a DDoS attack on AWS IoT Core. In that case, better we, for instance, deactivate the certificate or remove the permission so that no such attacks could be mitigated. So you can do that kind of automation as well, but in this case we kept it simple to simply get notification, because after that it's all about Lambda function to do the follow-up job. So that was all for this workshop. The last step is to simply go and clean up the resources so that you don't incur any cost for the resources post this workshop. So this was about the workshop. If you like this workshop, please click on the like button. Please subscribe to our channel to learn about this kind of labs in the coming days. In AWS, we provide many other such workshops and tutorials to our website, aws-dojo.com. And these workshops and exercises you can use to learn about AWS services. Each of these workshops implement a scenario like we just talked, and then when you implement the scenario, you learn about AWS services. If you have any feedback or comments, or if you have requests for any new content, you can either provide us the comment, the feedback in our comment section in the YouTube channel, or you can also click on the contact us tab over here to provide us the feedback. So I look forward to your feedback, because we try to listen to you and improve the content, create new contents which suits to our audience, to our readers. And again, requesting you, if you like this video, please click on the like button. I really need support and encouragement from your side. That is all for today, and see you again soon with some new video. Meanwhile, have a nice day. Bye bye.